edge AI accelerated hardware. Okay.
Yes. We got a lot of junk here. Okay, is that working?
Yes.
As you might notice here, there's potentially a lot of junk on this table. If you're way in the back, you might not have seen this junk. This is kind of important. This is the Raspberry Pi with an AI accelerator on it. And this is my little camera. This is just to be able to run the demo, which was working before when I got here. People saw it. So it's a little warm in here, so we'll see what happens. If it doesn't work, go to the GitHub. There's a video, there's an article. It really works. Or we could spend another 20 minutes trying to hack it, make it work, but it was working before.
I can watch for that.
See, there was one. That's a very honest guy over there. I work at Zilliz. We do the open source Milvis vector database and a lot of other cool open source stuff, especially around unstructured data. And I like to play with different devices just to show different stuff. Otherwise, you know, you see the same things. Oh, there's lots of cool stuff out there, but just trying to show something a little different. And Bill from AI Camp goes, oh, is it going to be the same thing? I go, no, this one's going to be different. Doesn't mean it's going to be good, but it's going to be different. That's my last name, which is also a research paper, so I'm hoping we add this to the database. So I'm talking to the engineers to see if they can add it so I can claim I'm in the database. I don't know if that makes sense, but it's cool to me. If you want to get the slides and you don't want to wait, I already put them online, so you can scan them. The page that's missing in the slides online is this one, because I had to upload it before I could put this in there. I should upload it again, but version control of slides, I guess. Yeah. Not that you need the slides, everything's in the source code, so you can try it out. You do need a couple of pieces of little hardware. Fortunately, the hardware is not expensive. It is Raspberry Pi 5, which is back in availability, thanks to them being able to produce them in England. I'm running on the 8 gig one, which is around $100. And I added the AI kit, which does AI and inference deep learning acceleration, which is kind of cool for 70 bucks. Not bad. Increases the throughput to 13 tops, which is pretty good. It's not an NVIDIA device good, but it's not bad for that price. Now, that's not really enough to break your very complex encryption. You know what will, though? Quantum computing. Now, that's still, does it actually work? Will it ever work? If it ever actually works, encryption is useless. Unless someone will write quantum encryption. And
we'll have to.
There's always, somebody's making money somewhere. And then we'll be, in 20 years, we'll be at that meetup showing us how to do some cool stuff. Or our robot images will be there.
Our robot overlord.
Yeah. Which they are my friends, I love them. Because they have just ingested this from some recording somewhere. So I love them. So, we'll do an introduction very quick. We'll try to get this demo working. It hasn't crashed yet. It's working there. And we'll show it through the screen. Some people, maybe it's a wide angle, you might get accidentally grabbed and stored forever in the computer, which is Minio and Slack and Milvis. That's my own on the little thing. If you've seen these other talks, I've been here a couple of times. I don't want to bore you with how databases work. I'm sure you've seen those. I'm sure you've seen how do vectors work. If not, You know, we have other material on that, and there's another talk next month probably. Couple things we do: hybrid search, filtering, sharding, support for GPUs. If you were at my meetup 2 days ago, we had NVIDIA in. We are collaborating with them on the Kagra index, which is the ability to do full indexes in their GPUs, which proved to be somehow cheaper. They figured out a way to be so much faster that it's cheaper than using CPUs. So you can actually put all the indexing into their recent GPUs and produce faster results. So we can actually run some pretty powerful stuff on the vector database and on the LLMs right on a device that can be in a robot or it can be in a little vehicle. It's not down to the Raspberry Pi level, it's down to the NVIDIA Orin level, which is a little more expensive, but not much bigger. I mean, the NVIDIA I have at home is the size of a small brick and lighter than a brick, but a lot more expensive than a brick, unless it was a brick of gold, but it's pretty cool. What's cool about our stuff, all open source, and it's flexible because everything you do is not the same, right? You might have images, you might have videos, you might have text, you might combine them, you might have JSON. You might want to search them super fast, you might want to search them super cheap. You might want instant results, but you're okay with a little bit of accuracy down, or you want perfect accuracy, and I don't care how long it takes. Or I don't have a lot of RAM, I have a lot of RAM. So we support a lot of indexes, because we work with a lot of different people around the world, so that you have your flexibility, you know. All the indexes you've ever heard of, they're in there. And include, not the Spann one, I'm talking to them about that one. But it's all the basic ones, because we've hired some of the people from Facebook who worked on that original one, and they're all working on the open source. All the type of searching that you could do, that you need to do. Some make more sense for different types of data, depending on how you want them back, how quickly you want them, all that kind of fun stuff. Of course, you can run a lot of different apps at once. And we're really low into the hardware level, because you sort of have to be for some of the research going on. You get your data, run an embedding model, put it in a database. That's really all you need to do for that. A lot of people have been using this database for a while, and it's nice. And again, all open source. You don't need, you can run it on a Raspberry Pi, you can run it on a small device, you run it in Docker, run it in the cloud, wherever. Cool little database, but we're not here for that, right? We want to see some weird demo. So, human pose estimation technique to match your joints, look at your eyes. It's kind of cool. I always think of that, I go, ooh, Terminator, but that's not a good demo. I mean, it may be a foreshadowing demo, but it's not a good demo. So I'm not doing that part. Though we could make a dashboard like Terminator and put where you are in the room and look you up.
But we're trying to convince people, yeah, it's not Skynet.
Yes. If you search my name, though, you may find some interesting demos, because I did have some association with the NSA. But none of that is accurate anymore. We don't do that stuff. So this is just going to be looking at things, and we'll map them out. Again, all open source. We map 17 different things, and we store them. And we'll do that in real time. From there, a couple libraries we use. This one here you may never have heard of. This is the people who developed the chip that runs cheap, low energy, very cool, and runs embedded on the Raspberry Pi. So this is a small AI accelerator chip related to some other ones, but they have their own specific libraries that enhance it for running in such an environment, running in an M2 connector, so it's as fast as you can get on this cheap little hardware. Oh yeah, speaking of cats, this is my cat. We have stickers in the back. Most of them have cats on them. This is what the source code looks like. I took some of their example source code and added some things. It is a lot of writing the word eye, ear, nose, throat. You feel like a doctor, but you're just copying code. So what we do at the end is we have the code that looks at it, maps it. Well, we collect all those points and we insert them in the vector database along with the vector of the image. So we put the image there and all the metadata. So we have it all together so we can do search or whatever we need to do there. And you know, what is the data we're grabbing? You know, whatever's coming off the vision from real world, images, video, audio, text comes up because we can run something like Olama on there. So we can run local language models and get those results and use them as part of the pipeline. And again, I'm running here on one device. If you're going to use this in the real world, maybe you have one device per classroom, per store, per moving vehicle, per truck. I worked with a water company and they had a shirt that had a smart device on it with sensors that communicated back to their headquarters so they knew what the oxygen levels were where the worker was. So they could get immediate feedback to say, hey, you're in a dangerous environment, you need to leave. And it would do this by changing the color of the shirt and vibrating. So they knew to get out even if they couldn't hear. Water workers are sometimes underground, can't always hear. So safety applications for this is not all evil in monitoring people. You can help people too if you want to. Again, we can run neural networks at the edge, Gen AI. This is easier on some of the bigger devices. Like if running on an NVIDIA Orin that has 256 GPU cores and 64 gig of RAM, I can run a lot of neural networks pretty well. Pretty decent sized model because they've optimized them to run on their GPUs. Now they don't run as fast on the little devices they do in their servers because they don't need to yet, but that is something that's going to happen. Whatever's happening in the cloud now, 4 years will be running on a device that's $100. Will be running on your phone. You know, they'll move the GPU smaller. They'll just go up. And they're already planning on that, the quantization, moving the bits down, through some tricks now. But the hardware always gets better. 20 years ago, this is unimaginable. Now we're like, well, yeah, I bought a $100 computer and now I can do, you know, real-time AI stuff. And I could send it to multiple places. Some are in the cloud, some are running on the Raspberry Pi, some are running on the laptop. Everything's distributed. We get our results back. If you want to try this stuff out, you got to do some heavy lifting here. Got to install Milvus, either Docker, or we have something called Milvus Lite. Just start your notebook with a pip install, and it runs it locally, so you don't need to install it. Or you could use online. People like to chat. Come on to our Discord. It is very friendly. We don't bother people. If you ask stupid questions, we don't think they're stupid. We're like, oh, that's a good question, and we'll give you a good answer. Even if it's pointing to the documentation of the first page. Hey, everyone has to start somewhere, and it's not easy. There's a lot in going on. So there's no, if you're doing the work to go to the page and get started, thank you. I mean, that's what we need in the community. You got to start somewhere, and then in a year, you'll come to us and go, hey, I've got 1 billion vectors in here, and look at the stuff I did. And we're like, cool, and you were the guy who asked the question, how do I do print? And we're like, yes. That has happened already. We've had some startups start off with people who couldn't get through the docs, and now they have real AI-powered applications running at pretty good scale. Why we have stuff on a device, the closer you get to the real-world stuff, quicker you get it in, quicker results. Sort of like if I've got a self-driving car, I really don't want to have those decisions go somewhere and then wait for them to come back. I want, not just that, I want any AI decisions to be powered by a local, instantly returnable database so that I'm not waiting for some model to reply. If the model don't reply, we go to the cache from the vector store so we know, hey, stop right away. Don't wait until the cloud says, oh, let's wait till we get our results back. Again, being able to search everywhere, keep the data, computation close. Also, so you own the data. If this is my data, I don't need to send it somewhere. I want to keep it locally. Maybe I use that for my own training and retraining, or maybe it's just private data I want to encrypt and keep away from other people. You know, pretty easy. We'll go back to questions in a minute because we probably want to see this work. Let's see. Hopefully it'll work. Now this is our little viewer of our data. It's called Atu, and it helps us search our data. So whatever data we have, we can search it here, doing a vector search and get the results back. It's pretty nice. I mentioned Minio. I'll show you that once we get this started so we can see the results coming through. Let's see if we can connect to our distant computer over there. This is probably the hardest part, is getting to a remote network. Oh, it ended. Let's reconnect. Can we make it? Uh-oh. Can we get to this faraway computer? Did it lose its network over here? If that's true, it makes the demo not as cool, but you'll be able to see it on this tiny screen if you come up here. It'll be like legacy applications. Let's make sure we didn't lose our login here. Manage access to it. Who knows what it is?
3 minutes ago.
Yeah, I mean, that's pretty recent. We should be able to connect to it. Very weird. What are you doing, tiny computer? You got to do one job, you know, just real time. It doesn't seem like that much to ask from it. Now, we might just run it there and we'll see the results as they get distributed among the cloud. Do we delete this and come back? What do you think? Let's delete it, see what happens. Okay. Maybe it's going to be mad at me now. Yeah, I don't want to reboot. That is not a happy place to be. No, we're not doing updates now. Anyone want to wait for updates? Probably not. No. Okay, we'll run it the old-fashioned way from the command line. Let's see. We may have lost our network. I don't know how friendly Microsoft is. Okay, so we are running here, and it's.
What is that?
It is grabbing the points. Now, you're not going to be able to see that because it's really small. Because I don't know how I would pack a very big monitor and bring it on a train. But what it's doing is it's grabbing, every so often it'll grab a picture from there and then upload it to Milvus and also upload it to my Slack channel. Again, I do a sampling because if I uploaded 10,000 of those, I don't think we got the network here for that. But
Latency.
the latency is a little much, again, because we're running on a Raspberry Pi that's mapping all these points in real time. And at 13 tops, if we ran this on an NVIDIA with 275 tops, we could do 30 frames a second. We're at like 10 frames a second, and then if there's a network blip or if something else is running on the system, because it is a regular Raspberry Pi, it's not an optimized real-time Linux. So it does a little bit. It does what it can. But I wonder if the connection came back. If we look over here, we can see we're uploading the data. This is a recent one. Uploaded it to my local Minio, which is running on the Milvus cluster. Milvus uses Minio for some of the caching. Now we're also sending the vectors to my cloud account here, which you can get a free one, and it just uploads all the metadata from where all the points are, and now you can take those points and draw your own from the base image that's there. And I link to where I put the image, and there's the very large encoding. It's a 384 dimension vector. You could use more, but that works pretty well for basic images. just to give you an idea there. It's still running. Well, pretty quickly, considering it's right there. Of course, I mentioned this when we started. I'm like, the remote connection's working now. I should have said, hey, make me do the talk first. What are you gonna do? We're able to run it. It's a little weird. Did it reconnect? It'll reconnect when I'm in the subway. And then we'll get some really interesting images. So we probably don't want those. Though that might look interesting on YouTube. So I'd keep that running until you see, if you see smoke, let me know. It's a little warm in here, we'll see how that runs. Besides our not able to connect to it, so you couldn't see this video. If you want to come up and look at this tiny screen, you can. We'll show that in the
hang
demo.
around and play with this after.
Yeah. So let's get to the questions. These are all, we got 5 minutes. So it's a good time for questions. I know it's getting a little late and, this is running, that's pretty much all it does. It just sends data to Slack and Minio and Milvis and keeps running this pose estimation, again, on the edge hardware. Does anyone have questions related to Edge AI, Milvis, vector databases, edge hardware? If you have questions about pose estimation, it's a standard library out there. Not too much. There is some new research going on with pose estimation using some of the larger models. And that work just came out, I believe, from Microsoft. I think that came out about a week ago. So we'll see when that comes available. Probably not on this tiny form factor, because it's pretty small that we're able to run it there. So any questions? Or this was too easy? Right in the front?
Yeah, what would be some practical non-governmental or non-military uses?
Yeah, one of the big ones that comes up is for sports. Sports is a common one. It's also used in some movie works to translate people's movement into animation, which is kind of cool. Used if you're trying to build cartoons, it's nice to be able to have what the real joint points work because they're moving. Also for some medical applications. Now within Milvis, we have the ability to store 3D images and vectors and move them in real time. So we have some research people possibly using similar things to get all the points to see like, well, how do you get a rotary cuff? How do you prevent it?
So
And for research. Medical, fitness, other ones, it's pretty much just for people. It hasn't been mapped to other animals yet. So, I could see this being good for veterinaries. You watch your pet and that's your dog coming and not someone else's dog out in your house, or it actually was a wolf. Security applications, but to me this just was a fun one because I haven't seen anyone do this model in a while. So I thought that would be cool to do. Show a different way of using a vector database and, real life stuff. Yes?
Hey, how's it going? So, thank you for your talk. I think this is really interesting, and I'm just wondering if you have any other ideas. What other cool projects are you interested in doing with Raspberry Pis and with Elvis and stuff like that?
Sure. With the AI kit, right now they have a small model zoo. Most of them related to vision and images, but on the other hand, they're getting pretty close to it being able to accelerate the running of some of the models on a llama. So if you find the right small model, you get a little acceleration, and you have a low-cost device that you could put anywhere for real-world interaction. Could be voice, could be text. You could set a lot of sensors available on the Raspberry Pi, so you could enter a room and have it turn things on for you, home automation, a lot of things like that. Data acquisition, changing. You can put this into a store shelf and have real-time changes happen. Tell you, okay, the temperature of this is too high. This needs to be thrown out, or this needs to be adjusted. And there's a ton of different models, or just image detection they have segmentation. It's all the standard, image deep learning stuff. Again, just starting to touch the LLMs. What's nice about having a vector database is being able to very quickly take images, text, video with extra data and get that stored, either locally, somewhat locally, on a server, in the cloud, very easily being able to search it, being able to use it for different multimodal RAG stuff, use it as part of an agent. But imagine having the agent being able to be distributed to an end environment with you. Like, say we're doing a meetup, I can have an edge device that knows, okay, this is how many people are in the room, this is how much pizza we should order next time. Scan how much pizza there was, how many people were here, how long they stayed, what was the temperature in the room, what was the light, and then combine that with other data you already have from Meetup and from other places and say, okay, this is how we should run it. This is how long it should be. Do people start leaving after a certain time? Is there a certain temperature affects things? And being able to answer questions for people, like instead of having someone have to run around, have a directional microphone that points to the person who raised their hand, and we could spot that up and go, okay, they raised their right hand. It means one thing. We'd have them raise the left hand, it means something else.
We have another question
Oh,
here.
yeah, I had a question around just kind of latency tolerant workloads. So a lot of the stuff here, I think LLMs only kind of work in the cloud still. I don't know, are there any good ones that are kind of useful on the edge right now?
Microsoft PHI 3, Llama 3 runs on here. And again, I want to use that as definitely as part of a RAG context, so you're not, trying to send every question in the world, because these are the ones with the smaller parameters. But they can still answer some good questions, especially if you could feed them good data. Like, instead of grabbing a video feed and doing editing on it, just grabbing sensor readings, grabbing REST endpoints, getting things like maybe current stock quotes or temperature, air quality, and then feeding that into the model from the vector database to get things like, hey, how's the room here? Like, AI Camp does meetups all over the world. Go, well, how is it in Mumbai's meetup, San Francisco, Shanghai, London, Berlin, and New York? Who's got the best temperature? In real time compare them and have the LLMs be able to answer those results because they get all the data and we can federate the data between them.
I see. So you are finding utility in having...
Yeah, I mean, I certainly could do a lot more on an NVIDIA box. But again, price going up. For enterprise uses, having a much bigger GPU and more memory and special algorithms that are designed for doing that. With the new NVIDIA NIM microservices, you can run lots of real world stuff. I mean, they're having robots able to move around, react to the environment, and answer questions. And they are not going to the cloud. Now, they can do that if they can't get an answer. If you get to a point you go, if I can't answer with the data that's local, I can go pull data or federate that out to a bigger model running in a cloud. But a lot of these things, especially if it's something gets asked the same questions all the time, like if you got a robot at an airport, you know what they're going to be asking. Why is there a robot here? Who's the guy's job that lost it? Where's my plane? How do I get there? And that can be pre-fed with that data real time very easily, because they do that in a dumb terminal. So I can get all those feeds in, plus any kind of tracker feeds. And even the small models can support multiple languages. Like there's some good ones for Korean. There's a bunch of languages that have already been trained. So you can have that even at the edge support 20 languages or more, depending on how big a box you're willing to get. And just have it focused on things that make sense for the environment. If I'm at an airport, I want flights, I want planes, I want where's food, bathroom. emergency stuff. You really gotta focus them on, not just have some. I don't want people being able to ask a question like, what's the capital of some random thing? I don't need to know that. Put what's relevant for that application there.
Thank you.
All right, we are at time. Sorry about that. Thank you so much, Tim. All right, this was amazing. One Raspberry Pi, you guys goes to my Amazon checkout page.
Yeah, they've gotten cheaper now.
Well, 2 goes into my checkout page. Anyways, thank you everyone for coming. The speakers are going to stick around a bit, I hope. So if you still have any unanswered questions, just go and talk to them. Come on, you can do it. And don't forget the pizza if you haven't taken a slice already. I mean, like, what's wrong with you, right? It's pizza. Who doesn't like it?
Thanks.
Just kidding.
There are no AI devices in the pizza anymore.
For now. Thank you for coming. Have a good rest
I
of the day.
mean, I don't have any use for it. I mean, storing all that.
Where's the Raspberry Pi?
The Raspberry Pi is back here behind my little monitor here.
That's the thing?
Oh, wow.
That's it. This is the AI kit. Is that little green topper on it?
And what's the specs of this?
It is, well, $70. It's 30 tops. It does not have a lot of...
30 tops?
Yeah. 13.
Because that is super high. Right?
It is
I mean,
for
it's not T-flops, but
for here. Yeah, it's not bad.
it's better than an M1 chip. Because that's T10 top.
And what helps it is the way that it's connected. Is
You can see little like.
it's got the M2 hacker for the faster connectivity that they just added for the Raspberry Pi 5. This is the chip part.